Today we're taking notes over targets 1 and 2. They're two very basic algebraic skills that you'll need to have for the rest of the school year, so they're super important. Starting with target 1, notice that the target says that I can simplify an algebraic expression. So we don't have any equal signs in these problems. We're just going to be combining like terms. So in order to do that, we have to know the order of operations. So the order of operations, there's lots of ways to remember it. A lot of students usually use PEMDAS, but I also have heard, please excuse my dear Aunt Sally, but we need to know what that means. So P, if we're talking about PEMDAS, P stands for parentheses. E stands for any exponents. We have to take care of those. Then M and D, multiplication doesn't necessarily come before division. So I'm going to put a slash here. Uh-oh. Let's get rid of that. Slash division. And then same with addition and subtraction. So it's not that addition comes before subtraction, they're on the same wavelength. And then something I actually already mentioned, but you can only combine two terms if they are alike. And so we'll talk a little bit more about what that means. Okay, so let's take a look at your first example. So your first example A, it has parentheses, which we've already talked about is the first order of operations. So in parentheses, in this case, what it's talking about is distribution. So we're going to have to distribute the 2x to the x. Let's start there. 2x times x is 2x squared. And then 2x times negative 7 is negative 14x. And then we have that plus 4. I don't distribute to that since it's outside the parentheses. If we think about being able to add or subtract these terms, we actually can't because they are unalike. We have x squared, x, and then no variables with the 4. So in this particular case, this is actually our final answer. And so that's kind of what makes simplification so difficult, is sometimes our answer is kind of ugly. So let's take a look at B. So B is similar to A in the fact that we have some distribution. So we have to distribute this half to the terms inside the parentheses. When I think about distributing a half, I just take half of the term. So 1/2 times 4x is 2x. 1/2 times negative 6 would be negative 3. And then again, we have to distribute to the second set of parentheses. This time is a 3. So 3 times 2x is 6x. Then 3 times 1 is 3. In this case, unlike A, we can actually combine some terms. So 2x plus 6x is a total of 8x. And then we have a negative 3 plus 3. So we could put a plus 0 here if we wanted to, saying that we combine those terms. Or we can just leave our answer as 8x. And again, that would be our final answer. This one's simplified much more nicely than A. Taking a look at C, on C we have a fraction. There's lots of different ways you can handle a fraction. My personal favorite way to do this is to actually break it into two fractions. So I'm going to start with negative 2x over 6. And then I'm going to use that plus sign, and then 24 over 6. The reason I like to do that is now I have two fractions that I can actually simplify individually. So negative 2 over 6 is just negative 1x over 3. So I change the negative 2 over 6 to negative 1 over 3. And 24 over 6 is 4. And again, we can't combine this any further because our first term has an x and our second term does not. So D has lots going on. It has a couple fractions in here. So I just want to remind you real quick that when you multiply fractions like we're going to have to do, you multiply the numerators together and then the denominators. So on D, we're actually going to start by multiplying 1 times the numerator and 2 times the denominator. So the numerator is actually pretty easy because 1 times 3x plus 2 is just going to be 3x plus 2. And then in the denominator, 2 times 4 is 8. Now for the second part here, it's actually kind of tricky because this 3 is not a fraction, so I'm going to put it as a over 1 so that it is written as a fraction. And I'm going to do the same thing, multiply the numerator, so that would be 3x, and the denominators, which would be 16. So the issue is at this point that we are going to be subtracting fractions, and now we do have to have a common denominator. A really quick, easy fix here would be if I multiply this 8 by 2, it would give me the 16 that I would need to match the other denominator, but I have to remember to also multiply the numerator by 2. So I'm going to rewrite here. I'm going to rewrite this problem with the first fraction being multiplied by 2. So that would be 6x plus 4 over 16 minus 3x over 16. And now I can combine these. So I can write this as one single fraction all over 16. So I have 6x plus 4 minus 3x. And then I can combine the x's in the numerator, which would give me 3x, 6x minus 3x is 3x, plus 4 over 16. And I'm running out of real estate here, but I'm going to take this a little bit further. Just like I did on C, I'm going to break this into two fractions. 3x over 16 and 4 over 16. So my final answer here would be 3x over 16 plus 1/4, simplifying that second fraction. Again, kind of ran into problem F there, but you get the point. All right, let's take a look at E. So E looks a little bit more difficult just because we have so many different terms. And so a lot of this is not alike. So we can't combine an x and a y or x squared and a y. So the first thing I'm actually going to do is think about this, as a -1 out in front of those parentheses. And I'm going to distribute this -1, which means I'm leaving everything in the first set of parentheses the same. So distributing the -1, -1 times -2x would be positive 2x. And -1 times y would be -y. And now we're going to combine like terms. So I see that we have a 4x and a 2x would be a total of 6x. And then we have a 2y minus 1y, which would be 1y. And then we still have that minus x squared that doesn't combine with anything. So this would be my final answer. So yet another example of when things start getting kind of ugly looking when we do this simplification process. And the last one here, start with parentheses, always thinking about that order of operations. So we're going to multiply this 1/2 x. So what we have to remember is we actually can multiply an x and y. So for example, when I do 1/2 x minus times a -6y, that's going to give me a -3, because 1/2 times -6 is -3 x, y. So we just include both of those. So then 1/2 x times 7x, that's going to end up giving me 7/2 x squared. And now I'm going to write whatever we have left, so plus x squared minus 7xy plus 8x. And then we just have to combine our like terms again. So we have two terms that have an x and a y, so we can combine those to be a -10xy. We can put these two together, and if you want to think about 7 over 2, if that's easier to think about as 3.5, that's totally fine. So 3.5 plus 1 would be 4.5. If you want to think about that as 9 over 2x squared, that would be fine. And then we still have that 8x, and again, we can't combine any further than that. So we just have to be really confident with our answer because they're not always pretty answers. So that's target 1. So notice none of these answers look like x equals a number, like what we're used to thinking about an algebra problem. When we go to the back, now we're going to be solving an algebraic equation. So these are all linear equations, and we're going to come across some tricky cases as well that you could come across on your homework or an assessment. So the goal here is to get everything that's alike on one side. So on A, we're going to get everything with an x on one side, everything without an x on the other. And there's lots of ways you can go about doing this. I'm going to actually start by subtracting this 7x over, which means we get rid of it on that side. So all we have left is a 2 equals 7x when I combine the 14 minus 7x plus 16. And then I'm going to subtract the 16 over. Since I had the x's on the right side, I'm going to get everything without an x on the left side. So that's negative 14 equals 7x. Now I'm always thinking about how do I undo when it comes to solving equations. So I want to undo this 7. So when we write 7x, that means 7 times x. So to get rid of the times or the multiplication, we're going to do the opposite, which would be division. And then negative 14 divided by 7 is negative 2 equals x. So this looks a lot more comfortable in terms of the answers we're used to seeing when it comes to algebra. I also like solving better than simplifying like we did on the front, because now we can plug in the negative 2 to our equation and actually see if it's a true statement. So it's super easy to check your work. All right, B. So there's one common mistake that I'll see a lot of students make on B, and that's that the first thing that they do is 5 minus 2, and they say that's 3. But remember that our order of operations says we have to do parentheses first. So the very first thing we're going to do is actually distribute this negative 2. We're going to leave that 5 where it is. So negative 2 times 8x is negative 2 times 4x is negative 8x. Negative 2 times negative 5 is 10. Equals negative 12. So working on combining like terms when possible. So 5 plus 10 is 15. Oops, I lost my x. Let's try that again. So we have negative 8x still, but then 5 plus 10 is 15 equals negative 12. And then we're going to go ahead and get everything with an x on one side, so leaving that negative 8x on the left. Moving this 15, I'm going to subtract it over to the other side, so I have negative 8x equals negative 27. I'm going to undo that negative 8. Now I don't have a calculator on me, so I don't know what negative 27 divided by negative 8 is. I know it doesn't come out evenly, so I'm going to leave it as positive 27 over 8, since a negative divided by a negative is a positive. I am going to make that change, but you can also give the decimal answer if you'd like. Alright, so let's take a look at C and D. These look a little bit more complicated. There's a little bit more simplification to do to start the problem. So as we've been doing, we're going to distribute to start with. So this will give me a negative 20x plus 32 minus 8 equals 56x plus 24 plus x. And I'm going to clean up each of these sides before I continue any further in the problem. So I have negative 20x and 32 minus 8, that would give me 24. And then over here, 56x plus one more x would be 57x. All right, so now I'm going to get everything with an x on one side, so I'm going to add this 20x over. Got rid of that. So now we have 24 equals 77x when I add those, plus 24. So again, if the x's, I put those on the right side, I'm going to put everything without an x on the left. So 24 minus 24, well, that's just 0, equals 77x. So at this point, I will see a large amount of students say no solution, and I understand why. The problem is it isn't no solution. and we can actually continue solving. So to get this x by itself, what do I have to do? Divide both sides by 77. 0 divided by 77 is just 0. So this isn't no solution, it's saying x equals 0. Different. Now let's look at D, and we can kind of compare and contrast these special cases. So again on D, the first thing we are going to do is not do 3 minus 4. We're going to distribute that negative 4. So leave the 3 where it is. Then that would give us negative 28x minus 28 equals negative 28x plus 71. So combining like terms over here on the left-hand side, so leaving the negative 28x, 3 minus 28 would be negative 25. And then I'm going to go ahead and get the x's on the same side. And then if you'll notice, it actually canceled both of them out. So we're left with a statement of negative 25 equals 71. So the difference between C and D is that C, up until the very last step, we still had that x in the problem. On D, we don't have any x's left, and we're left with a false statement. Negative 25 is not equal to 71. So this is an example of no solution. There is one more special case that you could see, and that would be, let's say we were solving and we got something like negative 25 equals negative 25. So again, no x's are left, but it's a true statement. This would be infinite solutions. So again, just kind of giving you that idea of what it would look like. We didn't have an example with infinite solutions on your notes, but that's what the final result would look like. All right, and then the last thing that you could see on this target would be, literal equations. So literal equations are when you are solving for a variable within a problem. So taking a look at E, it says solve for the variable b. So what we want our final answer to be is b equals something. And it's going to be a little bit of a mess because these aren't numerical. So I'm going to start by subtracting this 8x squared over. I think I said 8. I meant ax squared. So notice when I did 0 minus ax squared, it's just negative ax squared. I'm going to go ahead and subtract the c as well. When I subtract the c, it doesn't combine with the negative ax squared. Just kind of tacks onto the end there. Now to get b by itself, I would have to divide everything by x. And notice when I say I'm dividing everything by x, I'm dividing each term by x. So here we have our b equals, that's what our final answer was supposed to look like. And then let's simplify over here on the right hand side. So negative ax squared divided by x. So if there's x squared divided by x, that's just going to give us x. So negative ax minus c over x. We can't simplify that at all. So this would be our final answer. Super ugly. And then we're going to solve for r in the second equation. So this one's a little bit different because instead of all the addition and subtraction that we did on E, we're going to be dealing with multiplication and division. So to get r by itself, we would have to divide by 2, but also pi. So we're going to divide by 2 pi on both sides. The 2's would cancel out, the pi's would cancel out. So we have r equals c over 2 pi. And none of those are like terms in order for us to combine them. So again, those are called literal equations. And that's targets 1 and 2.